Hello viewers, I am Kausalya. Today we are going to solve problem related to AC parallel circuits. So here the problem is two impedances, right, are connected in parallel. Supply voltage is 200 volt 50 hertz. Find the admittance, conductance, susceptance of the combined circuit, right? And finally the total current and total power factor. So this is our given problem, right? Here you see 15 minus J10. So this indicates it has a capacitor, and here 10 plus J15, this plus J defines there is an inductor, right? So just draw the diagram here. Then the first step is we are going to calculate the values of Z1 as usual, okay? It's similar to the steps which we had given in the previous video. So the first thing is Z1. So how to calculate Z1? It is nothing but square root of R1 square plus XC1 square, right? So you see, since it is represented in ohms, okay, you should be careful with this. Here you see the unit is given as ohms, right? Therefore the value of XC and XL are given, okay? Don't simply take it as C and L, because if it is C then the unit is farad and L means it is in the form of Henry. So since here they are clearly mentioned in it as ohm, this is your XC value and this is your XL value. So here you see R1 square plus XC1 square. So we can just directly substitute the values here, and the value of Z1 is 18.03 ohms, right? We had calculated the value of impedance of this path. Then the next thing is we need to calculate G1. So G1 is given by R1 by Z1 square. Okay, these are all the formulas, you have to keep it in mind. So R1 value we know, Z1 we have calculated. So just substitute the value of G1 is, it is 0.461 mho. And the next one is we need to calculate B1. So B1 is given by XC1 by Z1 square. XC1 is given in the problem, Z1 we have calculated. So just substitute, and here the answer is 0.0308 mho. Here it is positive because of this capacitive reactance. The next step is we need to calculate Z2. So it is given by this formula, square root of R2 square plus XL2 square. And R2 is 10 and XL2 is 15. So when you substitute the values, here the answer is 18.03 ohms, right? And G2 is given by R2 by Z2 square. R2 is given in the problem, Z2 we had calculated. So just substitute, and here the answer is 0.0308 mho. Similarly, B2 is given by XL2 by Z2 square. So the value of XL is given in the problem, Z2 we know. So just substitute, and here the answer is 0.04461 mho, and here it is negative, right? Now the thing is, you see, we are going to calculate the total conductance, right? Total conductance is given by G1 plus G2. We know G1, we know G2, so just add. And next thing is total susceptance. So total susceptance is B1 minus B2, because here one path contains capacitor and another path contains inductor, right? So B1 minus B2. So just substitute, and so here the answer is, you see the answer is negative. So what does it indicate? It indicates that, okay, the inductive load is more predominant here, right? And the next thing is admittance. So how to calculate admittance? Again it is given by the formula G square plus B square. So here we have already calculated G and B here. So just substitute the values, and total admittance is 0.0784 mho, right? And the next thing is we are asked to calculate the total current. So total current is given by the formula V into Y of T, right? So V is given in the problem and Y of t, that is the total admittance we had calculated. So just substitute it here and the answer is 15.68 amps here. And the last thing is to find the power factor. So power factor is given by the formula G by Y, right? We know G, we know Y. So just substitute it here, and here that gives an answer as 0.981, right? So here comes the end of this video. In this problem, the main thing to be noted is if you make a simple mistake in the first step, then it affects the entire problem, right? Because the result which we got in first step, we are substituting in this next step, and it goes on, right? And again, the result which you got from the second step, it will be substituted in the third step. So they are interrelated to each other. So while solving this type of problems, okay, read the problem twice, write down the values exactly what is given in the problem, right? Check the values are correct and then proceed. Okay, while doing each and every step, do it carefully, right? So if you have any doubt, let me know in the comment section. Thank you.